Like forests on land, kelp forests under the sea provide food and habitat for many animals. They also sequester carbon from the atmosphere and turn it into food that fuels coastal ecosystems. Kelps are also very important to people, socially, culturally, and economically, due to their use as food, medicine, and a fishery supporting people's livelihoods. Globally, however, kelp forests are in decline due to a number of stressors, including climate change. This is causing coastal nations worldwide to seek solutions to maintain access to kelp and the many marine resources they support. These solutions may include relocating harvest of kelp to climate refugia, locations where healthy kelp is more likely to persist, or more dramatically, moving or transplanting kelp to these safe havens that are more likely to withstand marine heat waves and other climate impacts. However, these solutions depend on whether kelps do better when transplanted to climate refugia, no matter where they originally came from, or if kelps do better under the local conditions where they grew up. In other words, how locally adapted are kelps? This is an important question to ask because how locally adapted kelps are will determine their viability when transplanted and their vulnerability to changes in ocean climate. We set out to test this by conducting a kelp gardening experiment using giant kelp. We selected 6 giant kelp beds that spanned 50 kilometers and a range of environmental conditions of temperature, salinity, and water motion off the north coast of Vancouver Island. We created experimental kelp gardens by collecting giant kelp fronds, which are the kelp equivalent of a tree's branches, from all 6 beds, and measuring the length, number of blades, or the kelp equivalent of a tree's leaves, and size of a selected blade for each frond. We then attached fronds to floats about 1 meter below the ocean's surface. Each floating garden consisted of kelp fronds from all 6 beds, and we transplanted gardens to each of the 6 kelp beds and left them to grow for 1 month. After 1 month, we collected our gardens and remeasured all fronds, their length, number of blades, and size of the selected blade, to see how much each frond grew over the course of our experiment. If giant kelp are locally adapted, we would expect kelp fronds to grow the most in the gardens that were placed within their natural or home kelp bed, and the kelp fronds that were not originally from that kelp bed would not grow as much. In contrast, if giant kelp are less locally adapted, we would expect all kelp fronds, no matter where they originated from, to grow the most in the same gardens, ones that were placed at the sites with the best environmental conditions. Excitingly, when we returned to collect our kelp gardens, we saw dramatic differences in the color and growth of giant kelp after it had been moved to a different bed compared to its bed of origin. These differences could indicate that giant kelp is responsive to the environmental conditions in which it is growing, regardless of where it came from. Which would be good news for kelp, because it suggests that giant kelp in this region are not locally adapted. Rather, they're able to respond to and grow under different environmental conditions, and may be less sensitive to changes in ocean climate than we expected, at least across the range of conditions we tested here. However, this work is ongoing, and we're still evaluating the results of our kelp garden experiment through data analysis, lab work on collected kelp tissue, and conversations and knowledge exchange with local experts. Ultimately, we hope this work can help to inform climate-resilient kelp harvest and related fisheries by determining the resistance of kelp beds in the region to changes in the environment and identifying conditions that promote increased growth of giant kelp. Stay tuned.